So let's go back and talk about that. Remember, when you combine polynomials, when you add and subtract polynomials, combining and adding and subtracting are the exact same thing. What you're going to do is you're going to find like terms out of each group and just put them together. Leave the exponents alone. That's all you have to do. So for this one, I have a 5a squares here minus 2a squares, which is going to give me 3a squared. And then you have a negative 2b and a negative 7b, which is going to be negative 9b. Then you have a negative 4, because you have to distribute that negative through. So you have a negative 4 and a negative 3, which is negative 7. To classify this, remember your classifications. Monomial is 1, binomial is 2, trinomial is 3, or is quadrinomial or polynomial will be either. It doesn't matter. So since this is a 3-term polynomial, 1, 2, 3, then what we have is a trinomial. Now the degree is 2 because the degree for this term is 2, the degree for this term is 1, and the degree for this term is 0. So the highest degree is 2. So the degree for the whole entire polynomial is 2. You're going to see that again on your test, in your next test, which will be your chapter 3 test. Will be the 19th. So your chapter 3 test will be on the 19th. And you will have to classify your answers and tell the degree of your answers. So make sure you can do that. Alright, so let's go here. And this is just word form, but basically what you're doing is you're taking these word problems and making them into a math problem. So if it says add the given polynomials, basically what you're doing is you're taking this binomials and it's going to go to addition and you're going to combine like terms. So it's the same thing that we were doing. So we have negative 5t and negative 5t is going to be a negative 11t. And then you have negative 4 and 9, which is going to be a positive 5. So that would be your answer. What is the classification? It is a binomial. And what is the degree? It is 1, because there's a 1 there. Okay, so the one on the right, again, we're going to take these two binomials and we're going to add them together. We're going to try to go descending order. So 9x squared would be the first one. And then you have a negative 3x. And the only thing you have to put together are the 4 and the negative 6, which is going to be a negative 2. So what is the classification for this one? Good. And it is a degree of 2. Very good. Now, we talked about this the other day too. Subtraction is a little bit harder because you have to read what it actually says. This says to subtract this trinomial from this trinomial. So you're going to write it reverse order of what you're actually looking at. So what you're going to have is 7x squared plus 9x plus 8 minus 3x squared minus x plus 2. So you're going to write it in reverse order because it does say subtract it from. Subtract the first from the last. Now, if you want to cross the line, change the sign like what we talked about the other day, you're going to cross and change this to addition and take the opposite of everything inside. Or if you want to leave it as is and use your brain, that's perfect too. So you're going to have 7x squared and negative 3x squared, which is going to be 4x squared. 9x and 1x, which is going to be a 10x. And then 8 and negative 2, which is going to be 6. So the one on the right, again, it says subtract the first trinomial from this binomial. So the binomial is actually going to come first. And then the trinomial is going to come last. So again, if you want to cross the line, change the sign, you can, or if you just know what's going on. Your very first term, descending order, okay? So your very first term is going to be that x squared term. But it says minus a negative 5x squared. So that's actually going to turn into a positive 5x squared. And then you have 2x minus 6x, which is going to be negative 4x. And then you have negative 1 minus a negative 12, which is going to be negative 1 plus 12, which is going to be 11. Again, if it helps, cross the line and change all the signs. You have a trinomial with a degree of 2. That's right.
Can you do the second one on top again?
You're going to start with your highest degree. So you're going to start with the 9x squared. There's nothing to put with it, so we're just going to bring it down. And then you have a negative 3x. There's nothing to put with it either, so you're just going to bring it down. But then you have a positive 4 and a negative 6, which is a negative 2. There's 3 terms, so that's a trinomial. And the highest exponent you see is going to be the degree, which is going to be a degree of 2. Anything else? I know. See if you can turn it off. Alright. See if you can figure out how to set this first problem up. It is a word problem, kind of, sort of. It says perform the operations as described. Notice it says subtract this trinomial from the sum of this trinomial and this trinomial. See if you can set that up. And alright, let's see how we did. So according to this word problem, we have to find the sum of the last 2 trinomials. So to set this up, what you're going to do is you're going to have x squared plus 9x minus 4 plus negative 5x squared minus 7x plus 10. Now, addition is commutative. So it doesn't matter if you put the last one first and the first one last. That doesn't matter for those last 2 trinomials. And then from that, we're going to take away that first trinomial, 2x squared minus 7x minus 1. So this is how you could set it up. Or if you wanted to do the addition first and then write down that other trinomial, that's fine too. So since I have it written like this, what I'm going to do is I'm going to find every term that looks alike. So I have an x squared here, I have a negative 5x squared there, and I have a negative 2x squared there. So 1x squared and negative 5x squared is negative 4, and negative 2, which is going to be negative 6x squared. Again, if it helps, cross the line and change the sign.
That's when you're subtraction.
That's only with subtraction. And it only counts for the one that follows as well. Alright, so next we're going to start with a linear term. So I have a 9x and a negative 7x and a positive 7x. Well, the negative 7x and the positive 7x, those cancel out. So I just get a positive 9x. And then you have your constants. So I have a negative 4, a positive 10, and a 1. So negative 4 and positive 10 is going to be 6 plus 1 is going to give me 7. And again, remember, you are going to have to classify these and tell me the degree. So the classification for this one would be a trinomial, and the degree would be 2. Alright, so the one on the bottom. How many n squares do I have all total? Again, if you want to cross the lines, change the sign, you can. There's 1 here, and then there's a negative 2. So you have 1n squared and a negative 2n squared, which is going to give you what? Negative 1n squared. And you can write the 1 or not, it doesn't matter. Alright, so then let's go with the linear terms. We have a negative 7n and a 3n, and that's it. What are you going to get? Good job. Okay, and last but not least, we have a negative 9, a negative 4, and a positive 9. Well, what's negative 9 and positive 9? Yeah, there's 0. So we're just going to have, what, a negative 4? So again, trinomial with degree 2. Alright, any questions about adding and subtracting these things? All you're doing is putting like terms together. That's it. Alright, so let's start multiplying them. We're going to start off just multiplying monomials together, either a monomial times a monomial or a string of monomials together, whatever the case may be. Either way, your rules are the same. Now, this is where it starts getting a little crazy, okay? Anytime you're adding and subtracting the polynomials like what we just came through, don't mess with those exponents. If you're adding and subtracting polynomials, your exponents stay the same. However, when you start multiplying, that's when we're going to do stuff with the exponents, okay? So if you're multiplying things together, you're going to do that by adding the exponents. Now, your coefficients for the one on the top are 1, so we're just not really going to concentrate on those right now. What I want you to know is the rule. If you multiply like bases, because remember, when we have a power, x to the 7th, your base is here, and your power is here. So when you multiply powers with like bases, all you're going to do is add the exponents. So x to the 7th times x to the 8th is x to the 15th. You're just adding those exponents. Well, when we do throw the coefficients in, you have 2 steps. Number 1, multiply all your coefficients together. Multiply all your coefficients together. Those are the big numbers up front. So we have 3 times 4, which is going to be 12. Then what you're going to do is you're going to multiply like bases by adding their exponents. So here we have an x squared times an x cubed, which is going to give me x to the 5th. Add those exponents. And then what I have is I have a y to the 1st times y to the 2nd. Add them together and you're going to get y to the 3rd. Okay? Multiply your coefficients. And then multiply your like bases. So let's try the one on the right. If I multiply all those coefficients together, what am I going to get? 36. 6 times 2 is 12 times 3, which is going to be 36. Now, if I multiply all those x's together, how many am I going to have? There is a 1 here. Remember that. All right, so x to the 1st, x to the 4th, and x to the 3rd, you're going to add 1, 4, and 3. So you're going to get 8. And then y's, we have y to the 4th and y to the 2nd, which is going to be y to the 6th. Okay, so let's go back to pre-test day. Before we had the previous test. Classify both of these answers, or what? Both of these answers are monomials. You only see one term, right? There's only one term here. How do I know there's only one term here? It looks to me like there's 3. How do I know this is only one term? You don't see any addition and subtraction signs. If you don't see any addition and subtraction signs, there's only one term here. Okay, there's 3 factors, but that's not what we're doing. We're talking about terms, okay? So both of these are monomials. What is the degree of this one? 14. To find the degree of a monomial, remember this, to find the degree of a monomial, you're going to add all of them together. So the degree for this one's 14, the degree for this one's going to be 8. So monomials are a little bit different, so just be careful. Okay, now look what we're going to do. We're going to have a power to a power. So now not only for the inside power is x our base, but also for our external power of 5, now our whole entire x to the 4th is the base. Okay? So now what we have is a power to a power. A power to a power. If you have a power to a power, you're going to multiply those exponents. Do you see the progression? If you're adding and subtracting, you don't do anything with the exponents. If you're multiplying, you add the exponents. And if you have a power to a power, you multiply. So there is a progression. Every time you step up, there is a progression. So, to raise, and this is the key word here. The only time you can do this is if you have a monomial. If you have a binomial, trinomial, you cannot do this. Only if you have a monomial can you do this. What you're going to do is you're going to distribute the external power to everything inside the parentheses. Basically what that means is this. You're going to figure out how many factors I have. On the inside I have 1, 2, 3 factors. You're multiplying 3 things together, right? 1, 2, 3 factors. All 3 factors get raised to the 5th power. Most people get the x and y, but you leave out the -2. And you tell me the answer here is going to be -2 x to the 5th y to the 20th. This is wrong. Every single factor, including that coefficient, gets that 5. So what you're going to have is -2 to the 5th power, x to the 1st to the 5th power, and y to the 4th to the 5th power. -2 to the 5th power, you can put this in your calculator. You know where your exponent key is, or you should by now. -2 to the 5th power is going to be -32. X to the 1st to the 5th, you're multiplying. Power to a power, you multiply those exponents, so you're going to get x to the 5th. And then y to the 20th. Please don't forget the coefficient. When you start doing these, please don't forget the coefficient. Okay, so what about division? We just went through multiplying monomials. We just went through multiplying monomials. So if you're going to multiply a monomial, you're going to add the exponents. What's the opposite of multiplication? Division. What's the opposite of addition? Subtraction. And so that's what you're doing. If you're dividing, and again, keyword monomials, if you're dividing monomials, you're just going to subtract those exponents. And it's always top minus bottom. Don't forget that. It's always the top exponent minus the bottom exponent. So, what are you going to do with your coefficients? Well, when we were multiplying monomials, we multiplied the coefficients. Now that we're dividing them, we're just going to divide them. So 25 divided by -5 is going to be -5. Okay? So it's just like what we were doing here. If you're multiplying monomials, you multiply the coefficients. Well, here, if you're dividing monomials, you divide the coefficients. And then x to the 5th divided by x to the 3rd is going to be x to the 2nd. And I want to show you something. X to the 5th means x times x times x times x times x, right? 5 x's multiplied together, yes? X to the 3rd means 1, 2, 3 x's multiplied together. Well, let me ask you this. What is x divided by x? 1. X divided by x. And x divided by x. And x times x. So basically that's what you're doing. Okay? Okay, here's a little quiz. You can partner up if you want to in groups no bigger than 4. But I'm going to give you about 10 minutes. Alright, so for the first one, we're just have a monomial times a monomial, so it's coefficient times coefficient. 6 times 7 is going to be 42. X to the 3rd times x to the 2nd is going to be x to the... Good job. You're adding exponents. So the one on the right is the exact same thing, you just have 3 to deal with now. So 3 times -2 times 7, 3 times -2 is -6 times 7 is going to be -42. And then descending order, so we are going to start with the a's. A to the 1st times A to the 1st is A to the 2nd. And then B to the 1st times B to the 2nd is B to the 3rd. Alright, here, remember, every factor gets squared. So 8 squared is going to be 64. X squared squared is going to be x to the 4th. And y to the 5th squared is going to be y to the 10th. Remember, power to a power, you're going to be multiplying. Alright, the one on the right, that negative sign is going to stay outside. And so you're going to cube everything on the inside. So 3 cubed is going to be 27. A cubed is A cubed, and B cubed is B cubed. Alright, here, we're going to divide the coefficient. So 9 divided by 3 is going to be 3. And then we're going to divide your x's by subtracting the exponents. So 5 minus 1 is going to be 4. And y to the 4th divided by y to the 2nd is going to be y squared. How'd you do? Great. You ready to take tests on this now?
Yeah, sure.
No. Yeah. Okay, so let's see if you can apply the rules to these two problems. Alright, so for the first one, again, it's a monomial times a monomial. So coefficient times coefficient, 2 times 3 is going to be 6. To multiply your x's, you're going to add the exponents. Well, 1n plus 2n is going to be what? And that's all you got to do. Alright, the one on the bottom, your coefficients are 1, so you don't have to worry about that. But you're going to have x to the 3n minus 2 plus n plus 2. That's what you're doing. You're doing 3n minus 2 plus n plus 2. Because to multiply variables, you add the exponents. Well, the exponents just so happen to be binomials. So you're going to get x to the 3n plus 1n is going to be 4n. And then negative 2 and positive 2 go to 0, so they just cancel out. So you get x to the 4n. So if you know the rules and you have variables in your exponent, same thing. Same thing. Alright, distributive property. I've been doing this forever. What is 3 times x plus 2? Thank you. 3x plus 6. 3 times x is going to be 3x, and 3 times 2 is going to be 6. So what you're going to do is you're going to take what's outside the parentheses and you're going to multiply it times everything on the inside. Times everything on the inside. Number one mistake is people will multiply the 3 times the x and then they'll just leave the 2 out. So they'll get 3x plus 2. Please don't do that. Multiply everything on the outside times everything on the inside. Now let me ask you this. How do you know you're multiplying? Yes. There's nothing in between that 3 and those parentheses. That tells you that you're multiplying. Okay, so don't get that confused. Now, the one on the bottom, this is going to rely heavily on what we just came through. Because you're still multiplying a monomial times a monomial, you're just doing it 3 times. So you have 3x squared times 2x squared, which is going to be what? Good. And then you're going to do 3x squared times 5x, which is going to be what? Good. And then you're going to do 3x squared times 3, which is going to be what? So it's the exact same process, but now you're going to have to use your rules for multiplying monomials times monomials. Oh, man. What in the world? Alright. So what happens when you move up from a monomial times a polynomial to a binomial times a polynomial? It's still the distributive property, guys. It's still the distributive property. There's nothing in between. There's nothing in between the 2 parentheses. There's no addition sign. There's no subtraction sign. So this is how I know it's multiplication. Okay? So what I need to do is I need to multiply everything in the first group times everything in the last group. How many things are in the first group? How many things are in the last group? So when you finish multiplying, how many things should you expect? 4. If you multiply 2 in the first and 2 in the last, and you have to multiply everything together, you should expect 4 terms. And then you're going to have to simplify, of course. But, now, most people, how many of you have heard the full method? Okay, first, outer, inner, last. If that's what you use, go for it. I teach the distributive property. So, what we're going to do is we're going to do x times everything in the second group. X times x is going to be x squared. You have x to the first times x to the first, which is x to the second. And then you're going to have x times 8, which is 8x. So you're going to multiply that x times everything in the second group. Then what you're going to do is you're going to multiply that positive 3 times everything in the second group. So 3 times x is 3x, and 3 times 8 is 24. Is there anybody that has not dealt with the full method? Okay. So you know where these numbers are coming from. Good deal. Okay. Now, the multiplication part is done, but that's not your answer because you still have to simplify. Okay. The directions on the test will possibly say multiply and simplify, or it's just going to say simplify. Okay. This is not in simplest form, so if you put this on your answer blank, you're not going to get the whole credit. I might give you partial credit. But look at these two middle terms. Can you put those together? Why is it not 11x squared? I have two x's there. You're combining like terms. Leave the exponents alone. Leave those exponents alone. So what you're going to get is a positive 11x. Number one mistake here is people do that. People will say 8x plus 3x is going to be 11x squared, and then they put the 11x squared with the x squared and say, well, the answer is going to be 12x squared plus 24. Don't do it. Don't do it. The only time you're going to mess with those exponents is if you're multiplying. And here, when we simplify, we're just adding. Combine like terms. Okay, so what about a binomial times a trinomial? Same thing. You're going to take your x and you're going to multiply it times everything in that second group. Do that for me. Take the x and multiply it times everything in that second group. Write it down on your paper. Hopefully you got x to the third minus 3x squared plus 4x. Yes? You're going to multiply that x in that first group times everything in that second group. Now, don't forget that negative 3, because now what we're going to do is we're going to take a negative 3 and multiply it times everything in the group. Do that for me. So hopefully you're coming up with negative 3x squared, positive 9x, minus our negative 12. Don't forget your sign rules, okay? Positive times negatives and negative times negatives and so on and so forth. Don't forget those things. Alright, so multiplication's done. And if you'll tell yourself that, hopefully that'll remind you to not mess with those exponents anymore. Multiplication's done. Leave the exponents alone from here on out. So we're going to go descending order. So we're going to bring the x to the third down. Finish your simplification. Then you're going to go with your x squares. We have a negative 3x squared and a negative 3x squared, which is negative 6x squared. And then you have your x's. You have 4x and 9x, which is going to be 13x minus 12. Now it's simplified. Classify that. Polynomial or quadrinomial, I'll accept either one of them. And it is a degree of 3. Good. Okay, special patterns. Honestly, if you know the distributive property, the patterns don't really matter. When you're multiplying these things together, if you want to do the full method the whole entire time, that's fine. But if you want to know the patterns, if you pick up on the patterns, you can just look at your problem and write down an answer. I mean, you can do the math in your head, basically. What we have here, this is called a sum and difference. And the reason being is because your two binomials are exactly the same, except one's a plus and one's a minus. And it doesn't even have to be that order. It could be like that. It's just everything's the same except one has a plus and one has a minus in it. When this happens, when you multiply them out, those two middle terms that you can put together, you know when you do the full method and those two middle terms you should always be able to put together. What's going to happen is those two middle terms are going to cancel out. And so you're left with a binomial. So watch this. X times x is going to be x squared. X times negative 7 is negative 7x. 7 times x is 7x. And 7 times negative 7 is negative 49. These two are opposites. So they're going to go away. And so you get x squared minus 49. Now, today, probably not, but hopefully when I see you Wednesday, we're gonna start factoring. And factoring is the opposite of multiplication. So in multiplying, you start with your parentheses, you multiply it out, and you come up with a polynomial. Well, when we start factoring, we're gonna start here. And this has a special name because it comes from one of your patterns. This is called the difference of two perfect squares. I remember that from 098 in high school, whatever. The difference of two perfect squares. So if I ask you to factor the difference of two squares, it should go into a sum of difference. It's always going to factor into a sum of difference. Alright, so what about this? Notice the name of this thing. This is called a binomial squared. This is called a binomial squared. Do you remember what I told you when you were doing this? Or even this? Do you remember what I told you? Monomial is the key word. When you have a monomial, you can distribute that power. But when you move into anything aside from a monomial, such as this is a binomial. You cannot distribute that too. Okay? Here's the difference. If you have something like 4x to the second power, what is that? 16x squared, right? The two factors get squared. But if I have a binomial, what you're doing is, because up here, basically what you're doing is 4x times 4x, which is 16x squared. You take your base and you multiply it times itself twice. That's what a power means. Down here, you're going to have x plus 4, because that's your base. Multiplied out twice. Now this is what I want you to notice. If I take this binomial and I square it, I'm going to what we call expand it and full it. And I want you to do this. I want you to expand it and full it. Okay? So that you get the answer correct. Now this is what I want you to understand. And this is very, 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 very important. Are you listening to me say amen? That's weak. Are you listening? Okay. In this problem, the signs are the same. In this problem, the signs are the same. So those middle two numbers will not cancel out. They can't cancel out. Instead, they're going to double. Whereas in this problem, look at the signs. They're different. If the signs are different, then those two middle terms are going to cancel out. But if the signs are the same, they're going to double. Please keep that straight in your head. Do not tell me the answer to this problem is x squared plus 16. That's not true. I have calculus students that still do that, and it drives me nuts. A binomial squared is not going to be a binomial. It's just not going to happen. When I pull this out, I'm going to get x squared plus 4x again plus 16. Those middle two, they're not opposites, they're the same. They're going to double. So you're going to get x squared plus 8x plus 16. So what is the pattern? The pattern is square, double, square. Now, again, I just showed you that you can pull this out. So if you know the pattern, great. If you don't know the pattern, you're okay. It's fine. You don't have to know the pattern. But look, square, double, square. You're going to take that first term and square it. And then you're going to match the sign that's in your problem. And then if I multiply 4 times x, what do I get? 4 times x is 4x, double it, times 2. 4x times 2 is 8x. Always plus square the last. Square, double square. Just please don't tell me the answer to that is x squared plus 16. And in a minute, I'm fixing to give you a quiz, and I'm going to find out who's listening right now and who's half asleep. And it's all going to hinge on that problem right there. All right. The one we're going to talk about, this is new. Most of you didn't do this in high school, and I know we didn't do it in 098. So this is completely and totally new. What we're going to do is we're going to do a binomial cubed. Well, what's happening is you're doing A plus B times A plus B times A plus B, or minus. That's why there's a plus or minus sign there. Now, yes, you can full here, pull this out, and when you pull it out, you're going to get a trinomial. And then you're going to turn around and distribute. That's a lot of algebra, but if you want to be safe, then by all means, expand it and use the distributive property. Full the first two because it's order of operations. Okay, you have to multiply left to right. So you're going to full the first two and you're going to come up with a trinomial as your answer, and then you're going to multiply that trinomial times that next binomial. That's the distributive property, and that will work. Or if you want to know the pattern, you can do the pattern. The pattern says take the first one and cube it. Then you're going to use the same sign. So if I have a minus sign or a plus sign, you're going to use that. And then what you're going to do is you're going to do 3 times a squared times b. That's this. 3 times a squared times b. Always plus 3 times ab squared. Same sign. And that last one cubed. Memorize the pattern or learn how to do the distributive property really, 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 really good. It's your choice. So the problem that we have here, you can do this. And if you're doing this, go ahead and start working on it because it's going to take you a little while, and that's fine. First thing you're going to do is take those first 2 binomials and pull it out. And then once you pull it out, you're going to take that answer and multiply it times that last trinomial. Last binomial. Don't forget that last binomial, though. If you're interested in learning the pattern, watch what I'm going to do. In my pattern up here, I'm going to replace all my A's with 3x, and I'm going to replace all my B's with 2y. Okay? So I'm going to have 3x cubed, same sign, 3 times the first, squared times the second, always plus 3 times the first times the second squared, same sign, and then the last one cubed. And from here you just do the math. So 3x cubed is going to be 27x cubed. Now here you have order of operations, so you have to do the 9x squared first, and then multiply it times the 3 times 2y. So you're going to get a negative 54x squared y. Plus, same thing here, you've got to do the exponent first because it is order of operations. So that's going to turn into 36xy squared minus 8y cubed. And if you're going this way, you should come up with the exact same answer. You should come up with the exact same answer. Now again, I don't care what you do. Just learn how to do this. Okay? You can either do the pattern or you can expand it and use the distributive property. That's completely and totally your choice. But these are hard. But for those of you that are going into 112, those of you that are going into Cal 1, those of you that are even taking Trig 113, you're going to see this. So make sure you know how to do a binomial cubed. A binomial cubed. There is some logic to this. You know, mathematicians do have a little bit of logic going on. Watch this. You're going to take the first one and cube it. That's because of the cube. 3, because you have 3 terms. And then you're going to take, and it goes in descending order. Look at the A. A is cubed, squared, first power, gone. Do you see that? Cubed, squared, first power, then it's gone. Now let's go backwards. Look at the B's. You have B cubed, B squared, B first power, B's gone. So if that helps, I don't know. But anyway, binomial cube, make sure you can do this. Alright, yes.
On the plus or minus, how do you know that you need minus?
Because the pattern, same sign, and same sign, and then always plus. The middle one's always plus, and the 2 on the outside are the same sign. Middle one's always plus, and then the 2 on the outside is the same sign that's in your problem. So if there had been a plus sign there, all 3 of them would be pluses. Why is it negative? Why is what negative? This one here? Because it tells me to use the same sign that's in my problem. Is that better? Same sign, you're using the same sign that's in your problem. Alright, here's your quiz. This one